Hello again, friends. In this video we're going to be working with parabolas, and we're going to be trying to find the vertex, focus, and directrix with symmetry about the x-axis. So in order to get us started, right, the first thing that we have to do is make sure whatever we're given, whatever equation or function that we're working with, whatever our homework problem that we have is, we have to get it into our standard form. So with this problem that we have here, we can already see it matches our standard form, right? We have y minus k squared equals 4p times x minus h. We see that we already have that. We have y minus 1 squared equals some 4p term times our x plus 3. So now we got it in our standard form, but we have to remember that we're not always guaranteed to be given a equation in standard form, right? We might have to do some manipulation, we might have to pull out a term, or we might have to do some, you might have to complete the square. These kinds of things we have to keep in mind in order to get into our standard form. So make sure you're mindful of the fact that the first thing we always have to do is create our standard form. And remember, it can be one of two ways, right? Or we have one of two forms. We have x minus h squared equals 4p times y minus k, right? And so once we get it into our standard form, we have to identify which of the two we're working with, right? So we see that we have y minus 1 squared. So we know we're working with this one because our y term is going to be squared, not our x. So now that we've out of the two equations, we've determined the fact that this is the one we want to work with. In terms, we know that what it tells us is that our axis of symmetry, right, is always always identified by this term right here. Whenever's being multiplied by our 4p term, this tells us our axis of symmetry. So we know that when we graph this guy, how it's going to be shaped later on. So like I said, this tells us, our standard form tells us which equation we're working with and which axis of symmetry we're working with. So we've got our equation in standard form. We've determined our axis of symmetry, so we know that's going to be the x-axis in comparison with the other equation, which is in terms of the y-axis is our axis of symmetry. So we've identified that. Now we can start working on finding our vertex, focus, and directrix. So the first one that we're going to be working with is our vertex. Is the easiest part. So our vertex is determined by these two terms right here. Our h and our k. Our h and k tell us what our vertex is, the point that our parabola comes to. So, looking at our equation, we see that we kind of have a little bit different form because x plus 3. So what we have to remember, right, is that two negatives make a positive. So we have x minus negative 3. So what this really tells us, right, when you look at tells us our vertex, right, like we said. And we know that this is our h, is negative 3, and our k is just going to be 1, because we have our negative signs here, right? We have subtraction going on, so now we have our subtraction here, so we can just take our two numbers, so our 1 and our negative 3, and then those two make up our vertex. So now that we have our vertex, we can go about finding our focus and directrix. And these two terms are given to us by this guy right here. We have to look at our 4p. Our p term tells us the distance between our vertex and our focus. And as well, we can get our vertex, the distance between our vertex and directrix, because these two distances are exactly the same. And we'll see that when we graph. For example, this is going to be with symmetry about the y-axis, so it's going to be a little bit different in a minute when I show you. But if we have a parabola, right, I'm going to erase this for now, and we have our focus, we see that this distance and this distance are going to be the same. Here's our vertex, right, our focus, and our directrix. Because any point on our parabola, the distance from our focus to our directrix is always the same. So since the vertex lies right on that line, these two distances right here have to be the same too, right? And P tells us that distance. So P also tells us one other thing. If P is greater than 0, we know that our parabola is going to open towards the positive side of it's going to open towards the positive numbers. When P is greater than 0, when P is less than 0, the opposite's going to happen. It's going to open towards our negative numbers, right? So this way into our negative numbers. So knowing these things about our P, we can actually find P. In order to do that, we have to set these two terms equal to each other, right? So we know our 4P's out in front here. Out front here, we have our 1/4. So we're going to set these two pieces equal to each other. Do 1/4 equals 4P. We're going to solve for P, so we're going to multiply by 1/4 to cancel out the 4 here. So these two guys are going to cancel. Multiply the other side by 1/4. So we get a grand total of 1/16 equals our P, which we know P is greater than 0. So that tells us that we're going to be opening up this way. So now that we've found our P and we have our vertex, we can go find our directrix and our focus. So I'm going to get rid of this work here so we can do some graphing and kind of see what we're working with. Oh, my bad. Okay. I'm going to get rid of this. We know our P is 1/16. We know that's greater than 0. So, graphing now, you see, if this is our axis, our vertex is -3 is our x value, so -3, and we go up 1. So that's our vertex. So our parabola is going to look something kind of sort of like this, right? So our vertex is this point. We know our focus is going to be some point in here, and then our directrix is going to be some line over here, right? And the distance between these pieces, so this distance right here and this distance right here, that's determined by our P. It's going to be 1/16 away. So notice our y coordinate doesn't change, right? We're on the line when y equals 1, right? This is all the same, 1, y equals 1. The only thing that's going to be changing with our, between our directrix and our focus and our vertex is just the x value, where it lies on the x axis, right? It's moving from our vertex, we're moving 1/16 in, and we're moving 1/16 out. So, we know, like, our focus is going to be on the inside, like we said, because it opens up, like we determined our P is greater than 0, so it opens towards the positive values over here. So our focus is going to be on the inside. So when we try to find our focus, what we're going to be doing is we're going to be taking our vertex, we're going to be taking our vertex, which is -3, 1, because we know our 1 value, like I said, is going to stay the same. And we're moving towards the positive side, so we're going to be adding our 1/16 distance to our vertex, to our x value on our vertex. So that's going to be the same thing. We're going to have -3 over 1 times 16 over 16, right? Because we have to get our common denominator, plus we're adding our 16, and our 1 stays the same. Nothing changes there. So what that's going to get us is going to get us a -48 over 16 plus 1 over 16, 1, which gets us a grand total for our focus. I'm going to write it over here because I ran out of room. Our focus is going to be negative, since we add our 1, we're going to get 47 over 16, 1. That is our focus. So that is going to tell us at this point right there. So like I said, we have -47 over 16, 1. Now, similarly, we have to find our directrix. So our directrix is a line, is the difference, right? Our focus, we used our vertex point, and from there we just added our 1/16 to our -3, right? Our directrix is actually a line. So our line, if we were to graph the line that goes through our vertex, so this line right here, right? We know it's going to be x equals, because our x value is going to stay the same, and it's just going to be -3, right? A vertical line is always x equals that value. So -3 is the x value for our vertex. So that's the line through our vertex. In order to get the line for our directrix, right, we have to move this line to the left 1/16. So we're going to be, instead of adding like we did for the focus, we're going to be subtracting 1/16. So that's going to be the same thing like we said. We're going to have -48 over 16 minus 1/16. So our grand equation for our directrix, we're going to get x equals -49 over 16. That's our equation for our directrix. That's our, you can't see that, let me rewrite that. Our equation for our directrix for the line, right, is going to be -49 over 16. Because, right, we're moving our vertex to the left 1/16, and then the directrix of the equation of the line. So we're going vertical, so we know it's going to be some equation in terms of just x. So we're going to have x equals -49 over 16. Now, one thing you have to remember is if this were opening the other way, if our parabola is opening the other way, the way we'd be moving our focus and directrix would be different, right? If, for example, it went like this, our directrix would be a line on this side and our focus would be the inside, right? So what we'd be doing here, what we did right was we added our p-value to our vertex to get it to move over to the right. Here we'd be subtracting it, right? We see that this is our vertex. We're moving to the left, we'd be subtracting. So you have to keep in mind that we have to work in steps, right? Identify your vertex first. Identify your p-value. P equals, we knew, p equals 1/16, right? Our 4p was equal to 1/4. Evaluating, we got p equals 1/16. Then we recognize that that's greater than 0, so we were able to identify which way our parabola opens, right? So working in steps like this, we can easily find what our focus and directrix is once we know what our axis of symmetry, our vertex, our p-value, and which way our parabola will be opening. So that was how we found our vertex, focus, and directrix with our parabola that has the axis of symmetry along our x-axis.